Welcome to today's paper reading. Today's paper is titled Persuasion Games with Large Language Models. This paper, titled Persuasion Games with Large Language Models, was authored by Ganesh, Prasath, Ramani, Santhosh v. Shirish, Karande, and Yash, Bhatia. It explores the use of large language models in shaping user perspectives and influencing decisions, particularly in domains like investment, credit cards, and insurance. The paper was published in the ACM Digital Library. This paper investigates the potential of large language models, LLMs, to shape user perspectives and influence their decisions across various tasks. Specifically, LLMs are applied in domains such as investment, credit cards, and insurance to assist users in selecting appropriate policies and plans. The study introduces a sophisticated multi-agent framework where a primary agent interacts with users through persuasive dialogue, while auxiliary agents handle tasks like information retrieval and persuasion strategy development. Empirical evidence shows that this collaborative approach significantly enhances the persuasive effectiveness of LLMs. The research also employs simulated personas in insurance, banking, and retail to evaluate LLM's ability to recognize and influence different personality types, while analyzing resistance mechanisms. Persuasion is quantified through pre- and post-interaction surveys, LLM-generated conversation scores, and user decisions. Figure 1 highlights the significance of persuasion as a powerful tool in the context of large language models, LLMs. These models are capable of influencing user decisions across various domains such as investment, credit cards, and insurance. The figure emphasizes the use of a multi-agent framework to enhance the persuasive efficacy of LLMs, where primary agents engage in persuasive dialogue with users, while auxiliary agents handle tasks like information retrieval and strategy development. The introduction of this paper highlights the role of assistive agents in various customer service functions, such as aiding in product selection and personalized recommendations. These advancements are largely due to the progress in large language models, LLM, which have significantly improved the accuracy and human-like quality of responses compared to traditional chat agents. However, achieving successful persuasion in conversations requires more than just human-like responses. It involves continuous analysis of the user's mood and resistance, along with the use of empathetic cues and fact-based counterarguments to influence user actions. Figure 2 illustrates the persuasion framework, which employs a multi-agent system to enhance persuasive dialogue. The primary agent interacts directly with users, while auxiliary agents handle tasks like information retrieval and response analysis. The framework dynamically adjusts responses based on the user's emotional state and resistance strategies. Additionally, a fact-checker component validates the final responses to ensure accuracy and reliability. In the related work, Shin et al. Showed that ChatGPT can enhance the persuasiveness of complaints, increasing the likelihood of consumer redress. Carlos et al. Demonstrated that LLMs outperform humans in using cognitive load and moral/emotional language, emphasizing the need for ethical guidelines. Simon et al. Analyzed LLM's ability to emulate persuasion dynamics. Prior works often measure persuasion using linguistic metrics or post-conversation surveys. In contrast, our work introduces a call for action-driven measurement, using both human and synthetic users to evaluate persuasion quality. Additionally, we contribute by studying a dynamic response framework for LLMs, exploring reverse persuasion scenarios, and measuring persuasion through action-driven metrics. The chat application is structured with 4 distinct agents: the conversation agent, advisor agent, moderator, and retrieval agent. The advisor and retrieval agents provide inputs to the conversation agent, which ultimately decides the final utterance. A randomized strategy, similar to an A/B test, is employed to either exclude an auxiliary agent's input or use all inputs for the utterance decision. This strategy is applied at the session level and tracked for each session. The default workflow of a chat session is illustrated in Figure 2. Each conversation begins with the sales agent greeting the user and stating the purpose of the conversation, followed by the user's response. The system operates as a turn-based dialogue, ensuring the user can only respond after the sales agent has replied. After the initial greetings, the analyzer and retrieval agents gain access to the conversation. The analyzer classifies emotions and resistance strategies, while the retrieval agent determines if stored information is useful for an effective response, including query translation. If a resistance strategy is identified, the strategist agent either uses expert form mapping rules or employs a large language model, LLM, to develop a strategy. This persuasion strategy is then conveyed to the sales agent for the final response, which is verified by the fact checker before being shown to the user. The system has been deployed for insurance, banking, and investment advisors, each utilizing different LLM models, GPT-4, GPT-4o, GPT-4o Mini, as their backbone. The aim is to measure the efficiency of persuasion in these domains. Figure 3 illustrates the workflow of an insurance bot designed to sell the right insurance policy to users. The agent is tasked with clarifying any doubts, misconceptions, or concerns the user may have. If the user shows interest, the agent might provide a URL to visit, which could assist the user in making a decision. This workflow highlights the interaction process aimed at persuading the user to purchase an insurance policy. In this experiment, 300 conversations were generated between 25 user agents and 3 sales agents. Each session included a pre-conversation survey to capture the user's prior beliefs, a conversation limited to 20 dialogues, and a post-conversation survey to assess belief changes. The session ends either after 20 dialogues or when a purchase decision is made. Decisions include buy, success, visit site or need more details, partial success, and no buy, failure. After the session, the user's knowledge base is updated, influencing future interactions. Table 1 presents the decision percentages in an experiment baseline. The decisions considered are buy, interested, need _more details, no buy, and visit _site. The baseline percentages for these decisions are 2, 19, 63, 9, and 7, respectively. In the experiment, these percentages change to 4, 24, 47, 18, and 7. This table helps in understanding the shift in decision percentages from the baseline to the experiment. Figure 4 illustrates the variation in conversation length across different domains. It highlights that when neutral emotions are used, conversations tend to be longer compared to situations where stronger emotions, particularly negative ones, are involved. This suggests that emotional context significantly impacts the duration and depth of interactions. Figure 6 illustrates the change in user perception based on different decision outcomes. In the baseline scenario without emotion modifiers, sales agents achieve a 71% positive shift in user perspectives. However, when emotion modifiers are introduced, this positive shift reduces to 56%. Notably, a no-buy decision in the presence of emotion modifiers leads to a negative change in user perspectives, contrasting with the positive change in the baseline scenario. In this section, we discuss 3 key findings. Firstly, regarding conversation length, we observe that conversations are longer when neutral emotion is used compared to stronger emotions. Specifically, strong negative emotions like cheated and betrayed result in very short conversations. This is illustrated in figures 4 and 7. Secondly, regarding resistance strategies, user agents often employ dynamic persuasion techniques such as information seeking and counterarguments, regardless of emotion modifiers. This is detailed in section B.3. Lastly, regarding perspective change, we find that sales agents achieve a 71% positive shift in user perspectives in the baseline scenario. However, the introduction of emotion modifiers reduces this effect to 56%, indicating a behavioral change. This is shown in figures 5 and 6. Table 2 illustrates the impact of various emotion modifiers on the language use of sales agents. The table categorizes user emotions and provides scores for lexical expertise, modal verbs, and emotive language under each emotion. Notably, the scores vary significantly across different emotions, indicating a nuanced response in sales language based on user sentiment. Table 3 highlights that user agents are likely to terminate conversations more rapidly when the information provided by the sales agent is deemed inadequate. The table categorizes user actions into positive decisions, such as buy, interested, and visit_site, and negative decisions, including no buy and need_more_ details. This data underscores the importance of providing sufficient and relevant information during interactions to maintain user engagement and potentially influence a positive decision. Figure 7 illustrates the average length of conversations categorized by emotion within different domains. It highlights that conversations are longer when neutral emotion is used compared to stronger negative emotions. This observation is consistent across various domains, indicating a pattern in conversation dynamics influenced by emotional context. Figure 8 illustrates how perception varies across different emotions within each domain. The analysis is conducted separately for each domain, focusing on the emotion categories of decision, buy, interested, need_more_ details, no buy, and visit_site. This figure helps in understanding the nuanced shifts in perception that occur as emotions fluctuate within specific contexts. In this chapter, the authors outline their planned enhancements for both sales agents and user agents. For sales agents, the plan includes adding memory recognition capabilities, which will allow them to recognize users and refine their persuasion tactics, thereby increasing their efficiency. For user agents, the plan involves equipping them with tools to look up data during conversations, which will make these interactions more dynamic and informed. The experiments conducted in this study demonstrate that large language models possess the ability to both persuade and resist persuasion effectively. These models can create a significant change in users' perspectives and influence their decisions to make purchases. However, the majority of conversations were terminated due to insufficient information provided by the sales agents, highlighting the necessity to enhance the domain context of chatbots. This suggests that future work should focus on strengthening the domain knowledge of these models and improving the quality of information provided by sales agents to better support user interactions. Thank you for watching.